Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll review linear equations. So by the end of this, I want you to be able to understand how to rearrange and solve linear equations. So let's start with an equation like this. So I chose this equation even though it probably looks easy because many people often mess this up. So what we're looking for here is a solution, a value I can substitute for x to make this statement true. So people usually get mixed up with this because they think, what do I do with this 16? They don't know whether to add or subtract it. So when we're solving these equations, we need to undo everything in the opposite order to BIDMAS, the order of operations. So what we've done to x, it was multiplied by 3 first, then 16 was added. This is a positive 16. If I write a plus there, it doesn't change it. So my first step is to subtract 16 from each side. So I get minus 3x is equal to minus 8 minus 16, which is minus 24. So now I have to undo timesing by minus 3 by dividing each side by minus 3. Make sure you divide by minus 3 and not just positive 3. So 24 divided minus 3 is 8. 8 is the solution. If I substitute x for 8 here, I get a true statement. Let's look at this equation here, which looks a lot harder because there are many operations that have been done. So what I want to do is I want to first get rid of the fraction to make it easier. So if I times this side by 5, it will get rid of this fraction here. But if I times one side by 5, I must times the other by 5. What you do to one side, you must do to the other. So divide 5 times 5 cancel each other out. I'm left with this on the left-hand side. On the right-hand side, I need to times only the tops. You don't times the bottom. When you're timesing a fraction by a whole number, you only times the top by that whole number. So now to get rid of this fraction, I times each side by 3. Because once again, times 3 and divide 3 undo each other. So I'm left with this. Now what I want to do is expand the brackets. I haven't even begun solving yet. So 3 times 17, 3 times minus 2x, 5 times 11, 5 times minus x. So when you have the pronumeral, i.e. the letter, on both sides of the equation, you subtract the one with the lowest coefficient, the lowest number in front of. So minus 6 is lower than minus 5. So I'm going to subtract minus 6x from both sides. Of course, subtracting minus 6 is the same as adding. If I add 6x to this side, that'll get rid of it, and I will only have x's on one side. So 51 on the left-hand side. On the right-hand side, I get 55 minus 5x plus 6x gives me that. So now this is easy to solve. I just subtract 55 from both sides. The answer I get is x equals 51 minus 55, negative 4. If I substitute x for negative 4 here and x for negative 4 there, I get a true statement. Both fractions actually equal 5. So let's now look at a literal equation. So here we have an equation that has 1, 2, 3, 4 variables. We can't solve it, we can't come up with a solution unless we know 3 out of the 4 variables. Instead, what we're going to do is rearrange this equation so b is the subject. What that means is we get an equation that's b equals something. So we're going to follow the same process as for solving an equation. We're going to undo everything that's been done to b. So first thing that was done to b is I added a, then I multiplied by this. So I'm going to get rid of this first. So what I'm going to do first is times each side by 2. That will get rid of the fraction. So I get 2 times big A equals h times a plus b. So because it's h times a plus b, I now need to divide each side by h. So then the left-hand side becomes 2a over h. The right-hand side is just a plus b. Now to get b by itself, I'm going to undo adding a by subtracting little a, that is. So it's 2a over h minus a is equal to b, and we're done. This isn't a solution, we don't have a value for b, but we've rearranged it so b is the subject. Alright, let's now look at a worded equation problem. So at Goodberries, let's say concretes cost $1.50 more than milkshakes. I buy 4 milkshakes, 5 concretes for $75. I want to find out how much each item costs. So here, I'm going to first define my variables. That's what you always do with a worded problem. So I want to let X be one of the things I'm trying to find. So let's let it be the smaller one to make things easy. So it will be the cost of a milkshake. Now I also need to define a variable for the cost of the concrete because I need to find that too. Don't want to use a different pronumeral or letter for that because I don't know how to solve equations that have 2 variables or pronumerals. On the first slide, we were able to solve the equations because there was just one pronumeral, x, and on the second slide, all we could do was rearrange it to make b the subject because there were 4 variables or pronumerals in that equation. So instead of letting y be the cost of a concrete, I'm going to write it in terms of x. So the cost of a concrete is the cost of a milkshake plus $1.50. So that would be the cost of a concrete. So step 1 is define your variables as I've done here. So step 2, what I'm going to do is take this worded information and make it into an equation. I'm essentially going to rewrite all of this information using only numbers and mathematical symbols. So 4 milkshakes plus 5 concretes is equal to 75. This equation essentially says exactly the same as all those words there. So the final step is to solve like normal. So I'm going to have to first expand the brackets because I need to get x into one spot. So now I add 4x and 5x, and this becomes really easy to solve. You know how to do it from there. I'm going to subtract 750 from both sides. So I get 9x is equal to 6750. And then I just divide each side by 9. So 6750 divided by 9 gives me 750. So that means the cost of a milkshake is $7.50, and of course that means each concrete is $9. I just need to make one more step and write a worded answer to a worded question. So my worded answer here answers the question and shows I know what I'm talking about. Alright, thank you so much for tuning in to this video. This has been the luckiest maths teacher in the world. Have a great day.